Okay, Arduino robot by me. I got help from Alex, and Mr. Zach was going to help me code. So the problem was that the project was to design and build a quadruped robot. The rationale for this project was to enhance our skills in Arduino and other programs, as well as to prepare our experience with hands-on building and machinery. And the overall purpose was to build a walking quadruped robot from scratch. And the specifications for this project. So the objective of this project is to design and build a quadruped robot that can walk. The robot should be powered and driven by Arduino controllers. They should operate autonomously, and the structure of the robot should be designed in CAD and manufactured from any of the processes available to us in the engineering lab, including but not limited to 3D printing, laser cutting, and the CNC. All work should be done original, and we're not allowed to copy, but we can use projects as inspiration or guides. So the process, I started with the researching, and I researched the 5 different models. I also researched laser cutting, 3D printing, and the CNC to see which one would be the best to use. I ended up picking a design option, which was similar to Alex's, of course, because I was working alone, and it would have been really difficult for me to do this all by myself. I drew sketches, and I mapped out exactly what I would need to do. When I did the inventor modeling, I used other parts, like real-life parts, to get my dimensions, and also Arduino parts to get the dimensions. I did 3D printing, and when I did the 3D printing, it came out a little bit wrong, so I had to snip off some of the spiky parts that were coming on the 3D prints. That took me about a day, and I did do yellow and blue colors. Then, once I had the materials, I started coding, and I tried to construct the robot first before I started any of the coding, and I was going to code on Friday, March 12th, with Mr. Zach at the end of the day, but I did get contact traced again, so I couldn't do that, so I'm planning on coding it sometime next week when I'm back. Then I did put it all together, and that's what led me to be done with the project, or that's what will lead me to be done once I'm done coding. So the first concept was this Lego robot. This robot has smaller legs. It has an ultrasonic sensor, and much of the parts are sold online. That would be very easy to build, and it's a 4-leg robot with Lego compatible and an Arduino board. And then the website says that to do so, we take advantage of interesting mechanical mechanisms that stimulate the walking pattern of a real animal with only one DC gear motor. The result is quite interesting. So the criteria, the time constraint, everything is online and the instructions are mapped out very well, so this would likely be the most simple to do, especially because you kind of just have to connect everything since they are Legos. How hard is the code? The code is already online, and since all the parts would be the same size as the instructional one, there wouldn't need to be editing of the code. And then the inventor difficulty, this part is really what didn't appeal too much to me. So since they are Lego parts, they're very precise, it'd have to have a lot of circles. I don't see much of the parts online on the website, so it would kind of just be from pictures, and I don't know how I would feel about making parts just from looking at pictures instead of every individual part mapped out, like front, side, and back and everything. So I would need to model them in Inventor by measuring the Lego pieces on my own, which is also very time consuming and mostly estimating, which I feel like would make it a little inaccurate, and this would take a while since there are so many pieces to design, since every piece is so small. Is it appealing to the eyes? I actually really like how this one looks, and it also has a sensor right there in the front, the ones that look like little eyes, so that would be a big plus, and I think it actually looks very cute, and the wires are not all over the place. It looks really neat. And does it fit the specification? Yes, it does, and it does come with an ultrasonic sensor, which, like I said, is also a plus. So then, concept number 2. This description, it's described as a robot that is relatively inexpensive, acts like a mammal, and is easy to build with minimal coding. So the criteria for this one. The time constraint, it looks like the instructions are online, but it has a lot of servos, which mean a lot of time coding. I think it has 12 servos in total. And how hard is the code? It looks like the website provides some of the code, but much of the instructions are not as detailed as I would like them to be, since it is just describing the process that someone took to create the robot rather than providing instructions on recreating it. So it would be a lot of having to look over the same thing over and over again and kind of guessing what whoever made it did in between the steps that he shows us, because he doesn't exactly map it out step by step. So the inventor difficulty. The inventor parts would likely be very easy to create since most of it is just squares, rectangles, and geometric shapes. So there wouldn't be many curves or anything to do. I would just have to make the screw holes. And once again, the robot is symmetrical, so that would mean less parts to make. Is it appealing to the eyes? I do not think this design is very pretty to look at. It is definitely just for walking proposed rather than visual. I don't think it looks good, and I would make this just if I was in a time rush and I just wanted to get a robot done, but I wouldn't really keep this around. And does it fit the specifications? Yes, it does. So concept number 3 is this spider-looking one. I think this one is the most popular when you look up an Arduino robot. So the inner body moves up and down. It moves down when stationary and up when it is walking. It has 4 legs, and each leg is actuated by 3 servos. One servo is for forwards and backwards movement. Another servo is for up and down movement. The last servo is to allow for 3 degrees of freedom, meaning it can move in any direction. The drawbacks of this one would be that it does have 4 legs, so it would take more to model in Autodesk Inventor. It has a lot of servos, and it means that would take more time coding. So the time constraint, this is a very popular robot design, so there would be a lot of instruction online, and because of that, it may not take as long, because a lot of things would be planned out online, so there would be a lot to grab from. How hard is the code? Some of the code is online, but it was explicitly stated that it all depends on the weight and size of the robot. So it would need to be adjusted a lot, and I don't think I have the skill or time for that, since I am a slow worker, and I don't think I could understand the code. I did look at it, and it wasn't that legible to me. So the inventor difficulty, the parts seem not so straight and have curved and intricate details, which may be confusing and add to the time constraint, but it is symmetrical through the middle, and so that means that there would be less parts to make. So even though the parts are difficult to make, it would be less parts to make. I don't know if that would make up for the time constraint or not. So is it appealing to the eyes? This one actually looks really cool, and it does look like a spider, which is a plus. It does look appealing. The wires are kind of everywhere, but I think I could easily could have made something to cover that up. And does it fit the specifications? It has 4 legs, it looks durable, and will need to be programmed to walk autonomously, so I think it does fit the specifications. And then design concept number 4 is probably my favorite. So this one is described as... So maker Technovation decided to create a low-cost quadruped robot using 12 servo motors and a variety of 3D printed and laser cut parts. Each leg features 2 servos that move in line with the body, as well as one arranged with its rotation axis at 90 degrees. This enables it to walk forward and scoot side to side and perform a variety of twisting motions. This robot is powered by an Arduino Uno along with the sensor shield for easy motor connections. Inverse kinematics can be used to properly calculate servo moves, which is integrated into the device's control sketch. So the criteria. The time constraint, this one would take a regular amount of time. I don't think it would take too long or it would be too easy, but there are a lot of instructions online, and I think it is step by step. All the parts are listed and they're showed side to side, front and back, so it would be easier to make, and the materials are all there as well. The only issue is that it does have 12 servo motors, which is a lot to code, and looking back, I probably would have done this option or the Lego one, which I think was option 1. But because I was working alone, I didn't really have much to choose from. I kind of just had to go with what Alex had and what Mr. Zach could help me with. So how hard is the code? There are 12 servo motors. It's a lot to code. I think I already said that. And then the inventor difficulty. It has 10 total parts that need to be made. They can be done, but it will take time. So that is a lot of parts because they all are different. But since they are shown completely on the website, I don't think it would be that difficult. Is it appealing to the eyes? I actually really like how this one looks. It looks super cute and it looks clean. I like the color, and it also has a sensor in the front. Does it fit the specifications? Yes, it does. And then the last concept, which was concept 5, this is the one I went with. The criteria for this one. So first, the description. This is a sloth Arduino robot. It can move forward and detect the range to make a turn, avoiding obstacles. The code is already online. There just needs to be some modifying done to it, and it is a 4 servo robot. So the drawbacks, it has only 2 legs, which is not in the requirements, so I did need to ask permission to see if I could make it. And it kind of doesn't look as cool as, say, Concept 4 or Concept 3. Okay, so time constraint. It is, I don't think it would have taken that long to make this one because Alex did have already this one made, so I could easily just use her for help. She could help me make the parts, 3D print. So even though I was working alone, I think this one I would be the least stress making probably because I wouldn't really have to start from scratch. How hard is the code? Some of the code was found online. It did need some editing done, and I did need to ask Mr. Zach for help. I also didn't really understand the code, but after doing it, it made a little bit more sense. And it did have 4 servo motors, so once I had one working, it wasn't that difficult to get the other working. So the Inventor difficulty, this one was not that hard to make in Inventor. It was just a few parts, all relatively similar, and they kind of just all had screw holes in them that just needed to fit together. Because a lot of it was just making from screws and parts connecting like Legos, kind of. Is it appealing to the eyes? I think that this one may have been a little bit messy with the wires. I do like that it has the sensor, and it does look like an actual robot because it only has 2 legs, so it looks like a stereotypical robot. And does it fit the specifications? It does not fit the specifications. It only has 2 legs, but I asked permission, so technically it does. And this is the one I went with, but I kind of do regret not going for Concept 4 or Concept 1. So my project evaluation, overall the project was successful, but it took me a really long time to complete because I was not exactly sure where to start. To add on, if Alex had not helped me, I don't think I could have ever gotten the project done at all. Some difficulties throughout the project were definitely that I was out for a few weeks at the beginning. Now discussing the actual model of the robot, I wish that I would have reprinted some of the parts, and some of them had the extra spiky texture on one side because the structure was taken out too early from the printer, and that took me about a day, so it kind of wasted a day having to fix that. And any design modifications would consist of adjusting the elongated parts of some of the structure. Also, when I was trying to connect the parts together, they didn't fit together that well, so I did have to cut some of it down to make them fit nicely. So I do think that some of the measurements may have been wrong. Also, once I did start making the robot, I realized that I was missing certain joints that were really important to the robot, so I had to go back in Inventor and make those. So that was a waste of time, and I wish I would have been more precise at the beginning. But this is a video of how the robot is supposed to walk, and then this is a video of the structure of my robot. It's not coded yet because I was supposed to code it with Mr. Zach after school today, but I got contract traced before I could do that, but we will be working on that.